Hey, welcome to a new day and to a new app. Today we're going to start building the fourth app. So in this video I'll make a demo of what this app looks like, so you know what we're about to build in the next videos. So this app will be about processing Excel files. We have these three Excel files here in this folder. I'll give you these files in the next video. So these will be the input data and they look like this. So that's the first file, that's the second file, and that's the third file. So these files can be opened with Excel or another spreadsheet program, and each of these files have data about a particular invoice. An invoice is a document that a company gives to a customer, and this document lists all the products and services that this customer has purchased and also the total price of all the purchases. Now, these are the files where the data are entered by the employees of the company, and the purpose of our program will be to read each of these Excel files and produce an invoice, a PDF invoice for each of these files. So the output will be something like this. So that's the invoice for this file. So our Python program will be responsible of getting all the Excel files in this folder and get the first file, read the data of the first file, and produce this PDF invoice. So you see the invoice number will be taken from the file name. You see in the file name we have this number 10001, so that's the invoice number, and we have the date that is also taken by the file name. You see the date is here, and then we have a table here. We get the data from all these rows. The water pump melody purchased by the customer in the amount of 2 pieces, that's the price per unit, that's the total price, and our program will also calculate the total price of all the purchases. So the total price is not listed in the Excel file, but Python will calculate it, and then it will show these data here in the PDF file. So what are the benefits for you as a learner with this program? Well, the benefits are that you're going to go deeper into learning how to use the Pandas library to read CSV or Excel files. In this case, it will be Excel files, but the process is the same for CSV files as well. You're going to improve your skills with working with files, extracting information from files, from file paths, file names, and you're going to practice for loops even further. So all those skills and more will be included in this app. So I'll see you in the next video where we start coding. Thanks. Hey, welcome back. I'm very excited to start coding another app with you. And before we start, I have a tip for you that will enhance your learning. The tip is this: whenever you are watching a video, when I say that I'm about to do something, for example, let's say that I will say that we have to write a list comprehension to do this thing, then you can pause the video before I write that list comprehension or whatever it is, and you try to code it before I do it. Once you have written that line of code yourself, then you can play the video and compare your code with what I will write. Your code will be different from mine 90% of the time or more. That's not the point. The point is that this thing will make you thinking about solving problems, and the mistakes you will make will be an opportunity to learn things better. That was my tip. Now let's begin. Please create a project in your IDE. I have created a project already, and here I've placed a directory with these 3 Excel files inside. You can find these Excel files attached in the lecture resources in this video. So let's imagine a shop or a company where the employees sell services or products, and then they write these things they sell in Excel files. So they make one Excel file for each client. For example, this Excel file here, which corresponds to the third file with name 10003-2023, etc. This file has these three products with product IDs, the product name, the amount purchased, the price per unit, and the total price, which is the amount purchased times the price per unit. So that makes an invoice, but that invoice is in Excel. Now we want to send the users, the clients, some sort of documents, some sort of PDF documents or something else. In our case, it will be PDF documents, but we need to figure out an automated way to create these PDF documents, and that's where Python comes in. So by the end of the day, we want that all these Excel files to be converted into PDF files. So one PDF file for each Excel file. That's what we're going to do. And for that, we're going to do data processing and using for loops. So that will enforce your core Python skills. Yeah, let's do this. Once you do that, then you want to enable version control, VCS, enable version control, git, then add a .gitignore file, .gitignore. We have done this several times. Add .gitignore. You want to add that invoices folder as well, so right click, go to git, add, so they will become green now and they are ready to be committed. And also create a readme.md file. Add that as well. So here you can write, for example, what is this project? And then you can write the description here of the project. For example, something like that. You can go in more detail if you like. And gitignore will have the then folder and .idea. And that's it. Now we can do the first commit. Initial commit. And that would be day 25. And commit. Right. There we go. And then let's create our main.py file. Add it to the repository as well. And let's start coding. Now, do we have a front-end interface? Do we have a graphical user interface here for this program? That's a big question you should ask in the beginning before you start coding. And to answer that question, you should define who is the user of your program. Is it a general audience? Are you going to distribute this program to the world? Or is this program going to be used by a very small number of people? If you're going to distribute this to anyone, then you might want to create a graphical user interface, which could be a web app, so a browser-based interface where you create a web app with something like Streamlit, or it could be a graphical user interface for desktops, and for that you could use py simple GUI or other GUI libraries. But if you think that this is going to be used internally by your company or another company, so if the pool of users is small, then you might just want to have a script without a user interface. So a script which can be simply executed through the command line by someone who knows how to do it. And this was the case with a previous app where we generated this PDF template via Python. So there we didn't have a graphical user interface either. And for this one, we're also not going to have a graphical user interface. So these types of programs are some sort of automation programs. They are used to get some data and produce some other outputs. So they get some input and they produce some output. Such programs are usually written as simple scripts without graphical user interfaces. Another example of such a program could be a program, for example, which you can run and it cleans your duplicate files in your computer. So for that program also you just need to run the script. You don't need to interact with the script. So no graphical user interface for this app. Let's start coding in the next video. Thanks for listening to my advice. See you. Hi, welcome back. Let's begin coding, but how do you begin? Where do you start coding? That's a big question, I know, for beginners like you. And if you remember, when we had a graphical user interface, I advised you to begin from coding the graphical user interface, and then you can code the back end. But in this case, we don't even have a front-end interface, so where do we begin? How do you start coding a program? Well, let me tell you the secret. The secret is you should think about how to go from the input data to the output. That's what the program does. It gets some inputs and it produces some output, especially these types of programs which don't have graphical user interfaces. So the secret is to think of the program as an arrow line where the start is the input data and then you code things out until you produce the output data. So we start from the input data. The input data are these Excel files. So these are files on disk, but we need to load them into Python. So that's where we start. How do we get this data into Python? Well, I already told you about the pandas library. Pandas is the library we can use to read CSV data, but also Excel data. So we import pandas and install pandas. But the thing is, we have multiple files. So 1 file, 2 files, 3 files. And when you have multiple items, you should think about Python lists. So we should create a Python list which contains all these file paths. For that, you can use the glob module. So that is a standard module, a standard library. You don't need to install it. And you can say file paths is equal to glob.glob. And here you give the pattern. A pattern is, in our case, invoices, in my case at least. So this folder is named invoices. And it is located in the project directory, in the root directory. So we say invoices and we get everything inside invoices which ends with an XLSX. That's the extension. So you see this asterisk means everything with XLSX. You can also do .xlsx to be more exact. Now to prove it that you're doing all right, just print out the file paths, run the script, and see the output. So we got the 3 files correctly. We have the file paths now in a Python list. So next we need to read each of them. So when you do multiple things, you should think about for loops. So you need to go to each file paths. So for file path in file paths, so we're iterating over the file paths. And then for each file path, you do df is equal to pd, so the pandas library, which has this name now, dot read Excel. That's the method. For CSV files, we used to use read CSV. For Excel files, we use read Excel. Now, can you guess what I should put inside here? Well, inside here goes the path of an Excel file. Now, since we are inside a loop, the path of each Excel file is represented by the file path variable. So in the first iteration, that would be that first file. So all we need to do here is go and provide the file path as a variable. Now with Excel files, you also need to provide a sheet name argument, and its name should correspond with the name of the Excel sheet, because Excel documents can have multiple sheets. So this one has the name sheet 1. you see with a capital S. So let's provide that there. Sheet 1 with a space between sheet and 1. And that's it. So at this point, we can just print out the DFs to check if everything is going well. So this is like taking things step by step. We need to extract information from the data frames. But for now, let's just print them out. So run, you're going to get an error. And that's the error. So import error, missing optional dependency, open PyXL. What happens here is that the pandas library needs this library to be able to read Excel files. So what you can do is go to the terminal or go to Python packages and search for open PyXL. That's the library, install it. Wait for the installation to complete and then we will execute the script again. So there we go, I will run the script and I should expect the data frames to be printed out. And that's the output, so that's data frame number 1, that's data frame number 2, and that's data frame number 3. So at this point we have completed the stage of getting the input data and loading them into Python. So we got these Excel files and we created Python objects, in our case data frames, in our program. With that we can commit the changes, load the data into data frames, or you can be more specific, load the Excel files into data frames. And yeah, that's what we need to commit, the main.py file. That's the only change we did in this video. We changed the main.py file. We wrote this code. So with that, we can complete this video. We can mark it as done and we'll continue to the next step in the next video. See you there. Hey, let's continue with our program. What do we do next? What do you think? So currently we loaded the Excel files into Python in the form of data frames, pandas data frames. Now, the next step is to think about how to go from the data frames to the PDFs. And you already know how to generate PDF documents via Python because we did that in the previous app. So first you need to create a PDF object and we do that using the fpdf library, which you need to install. So in each iteration, we want to create a PDF document. And you can create a PDF document using that fpdf class with capital letters. So let's say PDF is equal to fpdf orientation. This will be portrait, so P, units will be millimeters, mm, and the format, let's keep it A4. So why am I putting this inside the for loop? Well, because we need one PDF per Excel file, right? So it does make sense to have it here. Then once you create the PDF object, you want to add a page to the PDF object. And then you want to start adding content to that PDF. So to add content to the PDF, you want to first have like a sketch of the invoice you want to create. So you can either create a sketch by hand on a piece of paper, or you can use Figma to design the invoice, or you can just look here at my screen where I have a simple invoice. So we will create something like this. So you don't have to write a sketch or create a Figma project. Just look at here and let's begin. So we have the invoice number and that's the actual invoice number. So that's a label we want to write and that's the number. Now to add text to a PDF document, we use the cell method. But before that, we set the font, let's say Family Times. Size is equal to 16. You can play around with that value if you like, but 16 should be good. Style B for bold, so that's bold text. And then the cell of that will be, let's give it a width of 50, a height of 8. So we're talking about this cell. and txt will be invoice number, just like you see it here, and then the number, we will get it dynamically from the name of the current Excel file. So if you look at invoices, you see that the name of the invoice is meant to be the first number. So 10001 for the first invoice, and then the number of the second invoice is 10002, and so on. So we will extract that via Python. How do we do that? Well, we should extract that name before we add the cell. So let's do it somewhere in here, perhaps. So first let's extract the file name. Because currently we have the file path. So the file path is a complete file path, including the name of the folder here, invoices / and then followed by the name of the file. But we need only the file name, and then from the file name we extract only that number. So first let's extract the file name. To extract the file name, you can use different methods, but one good way is to use from path lib import path, and then you do path file path dot stem. Let me demonstrate you here what I've just done. So in a Python console. So from path lib I imported path, right? And then one of the file paths will look like this, invoices followed by the name of the Excel file, which is, for the first case, .xlsx. So that's file path in the first iteration of the for loop. File path will hold that name. And what we're doing here is we're saying file name is equal to path file path. So if you check file name now, it's gonna be that path object. So now this is a special object, and this object, it's not just a string, it knows about this path, it knows that this is the folder where this file is located. So it's some sort of intelligent string which is specialized for file paths. Therefore, out of the file name we can extract the stem. The stem is like a property of this type of object. So that gives us that without the extension. So file name is that for the first iteration. In the next iteration it will be that file name. In the third iteration it will be that file name without the extension, of course, as you see here, and so on. So that means the invoice number is going to be file name dot split at the dash. So let's see what we get from that. Oh, we get this error because I should have done that here instead of that. So let me run that again. File name. So file name now is just a string, right? So with stem we extract only the string. So now we are in line with this code here. And then we do this again. So now invoice number is this list. But if we extract the first item of that list, which is item with index 0, so we want that item, now invoice number is that. So that's what we need. Right, so again, this gives us a list, but then we extract the first item of that list. So it gives us the string, that string. So let's add that index in here as well, 0. So invoice number is that, and now txt is an f string of that, and in the placeholder we put the invoice number. So the value of the invoice number will be placed in here. And then you can say pdf.output. Where do we want to save this PDF? Well, I'll create a folder here, PDFs, or yeah, something like that, PDFs. So that's a folder in the root directory of my project, PDFs. Therefore, I'm going to say here PDFs slash the name of the PDF. Now, the name has to be generated dynamically somehow, right? Because we have multiple files and we want to automatically give a name to each of these files. So it does make sense to have the PDF names similar to the names of the Excel files. So we're talking about dynamic strings here. Therefore, we use an F string again, and as the name, we want to place the file name. So the file name is this variable, which contains something like this. So that's for the first file, 10002 for the second file, and so on. So file name, but this doesn't have the extension, so for this we want a PDF extension. So that will create, if I place it here, will create something like this. You see, file name was a variable here in this Python interactive session, so we get that full string. And we're going to get the same dynamic string for all the files. So we're ready to run this script and see what PDF documents we have created so far. So my script ran successfully. Let's open PDFs, open the first file. Yep, that's what we got. So not bad. That's the first information we were able to inject in our PDF file. So we have some more code to go, but we'll do that in the next videos. Let's commit the changes for this. So that was create a minimal PDF for each Excel file. Yeah, that's what we did in this video. So before we commit, let's make sure that everything is added to the repository. Oh, perhaps these files should be added as well. So I'm going to add the PDF folder as well with all these files. Go to commit. Yeah, so these were the changes we did and commit. So that's for this video. I'll see you in the next one. Hey, now it's time to assess and refine your skills because I'll hand you the exercise for today, and that consists of creating a new program from scratch. So let me explain you what you need to do. First, you need to download the 4 text files from the lecture resources. These text files have some text inside, some descriptions about cats, dogs, foxes, and snakes. You should create a program which produces one PDF document of multiple pages, and each of the pages will have this kind of information. So first it has the name of the text file. So if the text file name is cat.txt, here it should be cats with a first capital letter. So C is capitalized here. And then in here should be the text that is contained inside that cats.txt file. The same goes for the other pages of the document. So it's one PDF file with multiple pages. Here we have dogs, and then we have foxes, and then we have snakes. That's quite an interesting exercise that will really refine your skills about for loops. It makes you think how actually for loops work. So don't miss this. But for today, all you have to do is to create this PDF with only the names of the files. So don't worry about printing out the text in the PDF for now. That's something you'll do tomorrow. So today the task is to have the names here: cats with a capital C, dogs with a capital D, foxes and snakes. So please download those text files from the lecture resources and create this particular PDF document. I'll see you in the next video where I explain you the solution. Thanks. Hi, in this video I'll show you my solution to the exercise which I gave you in the previous video. So I wrote the code in main.py, And before I go through the code, I want to show you what my program produces. So I'll run main.py where my code is located, and that's the product. So we have this PDF with multiple pages, cats, dogs, foxes, snakes as text in each page. So let's go through the code. Before I started to write the code, I placed the 4 text files inside this files folder. Now, you could have also placed these files directly in the project directory. That's also fine. However, I do recommend that you place input files in a particular folder so that you don't pollute your project root directory with multiple files. It's better to keep things organized. Once I placed those files in the files folder, then I started to write the main.py file, importing the necessary libraries here. Then I created a list of file paths, so that will contain all the file paths of my text files, these text files. Then I created one PDF document with multiple pages. Notice that I placed this line of code outside of the for loop. So we're creating one PDF document of multiple files. Notice the word one PDF document. So since you are creating one document, that document creation code should be outside of the for loop. And since you are creating multiple pages, notice the word multiple. That means the code which creates those pages should be inside the for loop. So once you create the PDF document, then you can add pages with the help of the for loop. You want as many pages as you have text files in here. So 4 text files, 4 pages we will have. And then we extract the name of each of these files, since we want cats as the title here and dogs and so on. So that's what I do here using the stem property of the path object. And then I capitalize the first letter of cats using a title method. Here you could have also used a capitalized method, that's also fine. Afterwards I set the font in here for the next cell I'll add. So that's the cell that adds the name. The name here is cat in the first loop. In the second loop it will be dogs, in the third foxes, and then snakes with a first capital letter. So we add the cell and that's it. Then we produce the PDF. But look here, the PDF production line is outside of the for loop. So with this exercise, I'm sure that many of you have done some mistakes, like placing this inside the for loop like that, and maybe you ended up with multiple PDF documents, or perhaps you created the PDF object inside the for loop, and that would also create multiple objects. So this was a great opportunity for you to improve your skills regarding the for loop. This is not about creating PDF documents. So we're using PDF documents as an example to practice core Python skills which you'll need in many areas, and not only creating PDF files. So with that, thanks a lot and see you in the next videos. Please open a Python console and do import this. Execute that, and what you'll get as output is the Zen of Python. The Zen of Python is a set of principles about coding in Python. Now, PEP 8 was more about the syntax. It was more about the details of the syntax, such as spaces, indentation, etc. And these principles are more about the style of coding, more from a software engineering perspective. So now we will go through each of them and explain what they are for and what are they trying to guide us regarding the style of programming. So these principles were written by Tim Peters, which is a programmer and a contributor of the Python programming language, and also a great contributor on Stack Overflow, having helped the Python community for years on Stack Overflow. So these principles now are part of the Python interpreter, so that's why we can import them through the this standard library. Let's begin. Python is better than, beautiful is better than ugly. This first principle advocates the readability of your programs. Python is a programming language which is programmers oriented rather than being a language which optimizes the speed of programmers. So by having programs which are readable, that means you can communicate with other programmers easily. So someone writes some code, you can easily read it, understand it, and you can also read and understand your own programs. So the code should be beautiful. The second principle, explicit is better than implicit. Very often when you write programs, you might have different ways to do something. For example, let's say you have some text and you want to split this text using the split method. Now you can use the split method as it is, like that, and that will split the text at the spaces. So this is an implicit use of the split method, but it's better to use split and a space so that you explicitly declare here that you're splitting the string at the spaces. So both these two lines should give you the same output, but the second line is more explicit and it is better. So that's what this principle is about. The next one is simple is better than complex. And we also have complex is better than complicated. So these two basically try to say that your code should be as simple as possible, which again points to the point that programs should be readable and programmers oriented. Flat is better than nested. This points to the fact that in projects, for example, we have main.py here and backend.py in here. It's possible to create a folder in here like this folder and then place backend in that folder, right? And then you would import backend like this. So from folder .backend import get data. However, this is not what the Zen of Python recommends. So it's better to have that backend.py file outside in the project here. So let me put it back where it was. And so in that case, you simply import it from backend import get data. So you import the get data function from there. So you shouldn't use nested namespaces. Although that is possible, so sometimes you might have to use it when you have too many files, but try to avoid it. So let me delete that folder and go back to the Zen. Sparse is better than dense. Let's take another look at backend.py. Here, for example, 11 and 12 of these lines. Here we are creating a response object with request.getURL, and then we use that response object to get the JSON data out of them. Now, these two lines could have also been just one line, so we could have just applied .json in here, and that means our code would be shorter. But this would be also a dense line, so that is not recommended. It's not encouraged to have dense lines, but you should have your code sparser. So it's better to split things at different lines. Right, the next one is readability counts. This is actually related to this. So basically you should have your code sparse, but you should keep readability in mind. So sometimes it might not be a good idea to have sparse code because you should also think about readability. So some of these principles are related to each other. Special cases aren't special enough to break the rules. This line basically talks about the principles, so you shouldn't break the principles, although sometimes you have to break the rules. So the principles are starting to become more artistic as we go through the last ones. The next one is errors should never pass silently unless explicitly silenced. Let's look at our main.py file to explain this particular principle. As you might remember, in this app, when the user entered a city or a town name which didn't exist, the user would get an error on the web page. However, the program, the web app, would still work. Now, if we left that error just stay there and ignore it because the app was working, then we would have let the error occur. But what we did instead is we captured that error. So we silenced the error using this key error here. So this except statement. So basically the error is occurring, but we show the user this message. So that means we didn't let the error silently happen. So we handled that error using the try and except block. Right, the next one is, in the face of ambiguity, refuse the temptation to guess. This is about making sure that the code you write does what you think it does. So never let any place for ambiguity, for uncertainty in your code. So make sure that it does what you think it does. The other one, there should be one and one way to do something. Although that way may not be obvious at first unless you're Dutch. So the principles are becoming jokes rather than principles at this point. So the idea here is that Python encourages the use of one single way to do something. But there are cases, for example, that the creator of Python, which is Dutch, did things different ways. For example, formatting strings. There are different ways to format strings and not only using the F string. For example, you have this variable, hello. One way is to use the F string, a and the dot, and you get that. But another way is to use this format operator. So you'd say this dot or anything you can write here, and then a dot here after a string, and then after this you make a space, a percentage operator, and then the a variable, and that should give you that. So these two do the same thing, but this is the old way. Actually, it still works, but it's the old way. So even the creator of Python has broken this principle. So that's why it says you should follow this principle unless you are the creator of Python, which is Dutch. Now it's better than ever, although never is often better than right now. This points to code which has infinite loops, and it's better to not use such code which gets lost in infinite code, although it's also better at the same time to wait for that program to finish instead of getting incorrect output. So that's what these two aphorisms are about. So these two are more holistic than practical. Then we have, if the implementation is hard to explain, it's a bad idea. If it's easy to explain, it may be a good idea. This again points to the fact that Python is oriented towards programmers, so you should be able to explain your code to other people for it to be understandable. And we have reached the last principle. Namespaces are a great idea. Let's do more of those. So in Python, each module or function has its own namespace in which variables reside. So you might have local variables in a function, you might have a global variables in a module. So each of these variables, the variables of the function, belong to the function namespace, while the variables of the module belong to that particular module. So namespaces are a way to categorize. It's the way of Python to categorize names. So these were the principles I wanted to talk about. So I hope that gives you some better idea on the code style. So it helps you to know Python better. And yeah, let's talk again in the next videos. See you.